online 5-day faculty development program on research and technologies of AI. Ladies and gentlemen, on the second day of FDP, we will be having 3 sessions. The first from 10 a.m. to 11:30 a.m. on techniques of artificial intelligence and its implementation in Python. The second session will start from 12 noon to 1:30 p.m. on a tour of Python, and the final session will be from 2 p.m. to 4 p.m. on Sahaja Yoga. So you can ask your queries by raising your hands, or you can type it out in the message box at the end of each sessions. So all dear esteemed participants, let's begin with session. It's a proud privilege to have Dr. Sujata as a session speaker. I take this opportunity to introduce to you all. Dr. Sujata is currently working as an assistant professor in Department of Computer Science and Engineering, the North Cap University, Gurugram, India. She has an excellent experience of 13 years in both industry and academia. She has completed her PhD in computer science from Banasthali Vidyapeeth, Banasthali. She has received MTech software engineering from MDU Rohtak. Her current areas of research include software engineering, software testing, data mining, machine learning, and practical SWAM optimization. She has published 17 papers in peer-reviewed international journals and reputed national and international conference proceedings. She has also co-authored 2 book chapters from international publishers. She has been the co-editor for Souvenir of 2014 IEEE International Advanced Computing Conference. She has been served as reviewers of various international journals, Corpus Index mainly. She is also the member of Technical Reviewer Committee of various IEEE conferences. She has been awarded state-level scholarship during her post-graduation. Welcome you, ma'am.
Thank you so much. Thank you so much for this warm welcome.
Thank you, ma'am. Ladies and gentlemen, let's have a great learning today. So, Sujata, ma'am, it's over to you now. You can proceed with the session.
Okay, before I start my session, first of all, I would like to thank you, IILM Academy, IILM family, for giving me this opportunity so that I can share. Basically, I can discuss. Not this is actually sharing of knowledge. So I'll not call it as a session. I'll call it as a discussion platform. So I'm really thankful to all.
Sujata ma'am, please unmute yourself.
Ma'am, you are not audible. Right now you are not audible. Now you are.
Okay. First of all, I would like to thank you so much. I would like to thank ILM family for providing me this opportunity so that we can share the knowledge, we can share our understanding on this topic, which is artificial intelligence and its various techniques. So just give me a minute so that I can share my screen. And I hope it is visible to all of you.
Yes, ma'am, it is visible.
Okay. Okay, so today's topic for the discussion is Introduction to Artificial Intelligence and its Techniques. I'm going to start this discussion with this beautiful thought and with this beautiful quote, which is the illiterate of the 21st century will not be those who can't read and write, but those who can't learn, unlearn, and relearn. So it was quoted by Alvin Toffler. As we are talking about the artificial intelligence means we are talking about the learning, we are talking about the predictions, we are talking about the reasoning. So I think this is a very good quote to start this discussion on artificial intelligence and its techniques. Now, these are the topics that I'm going to cover, which are introduction, major AI techniques, machine learning, classification, In the classification, I'll be more focusing on decision tree and its implementation because we are going to cover in the Python. So that's why I'll be focusing on decision tree. In the clustering, I'll be focusing on k-means and its implementation in Python, and then the conclusion for today's session. So before I switch to my main presentation, I just want to present some statistics on artificial intelligence. According to, I'm just presenting 2-3 surveys report, and then I will switch to the main topic of the presentation and main topic of this session. So according to the survey which was performed by Gartner in 2019, the number of business adopting artificial intelligence actually grew by 270%. Means if we can say, then 30% of the organization in today's world, they are using artificial intelligence. So we can assume how much it is growing, artificial intelligence. So basically we are living in AI era. So this is the survey that was performed in 2020, which is showing the AI impacts on the industry growth. So according to this survey, market size have been grown to 80%. If we talk about this this survey is conducted till 2000 based on the data of 2020, and this survey tells us the prediction till 2030, that by the end of 2030, our most of the organization will be towards the artificial intelligence, and the market size growth will be 80% in this area. So as I earlier told you, by the Gartner survey, business adaptation for this artificial intelligence era is 37%. So basically the companies are facing the challenges because they have not the skilled person, they have not the trained staff members so that they can use the artificial intelligence in their businesses. So 59% of the organization are facing this problem that they don't have the skilled person. So we can understand if we introduce this artificial intelligence subject in our curriculum, so then that will give a very bright future to our students. So another survey, another aspect that have been proven in this survey is that enhancing the feature, functions, and performance of their products. Basically, why we are using the artificial intelligence, why we are using artificial intelligence in our various industry. So there must be some objective. So the objective the companies are for which they are using the artificial intelligence is basically enhancing the features, functions, and performance of their products. So basically, they want to optimize their business. The one line or baseline, we can say that. But yes, if we are opting and if we are adopting the artificial intelligence in such huge way, there will be impact on our job also. So as per this survey, by 2025, 16% of US jobs will be taken over by the robots, or you can say by the agents, or you can say the product of the artificial intelligence. So artificial intelligence there is need to fear from artificial intelligence? No, actually we should able to learn with this artificial intelligence. We should learn how to live with this artificial intelligence. We should learn how to opt the various like thinking, various reasoning skills that we use in case of the artificial intelligence. So this is the required thing from all of us, especially from educators. This is the another survey that tells that predict the business enhancement in case of artificial intelligence in this AI era by 2025. Like 44% decision support system will be based on the artificial intelligence. There will be 24% agents that will perform various tasks in businesses. For example, in various sectors, for example, we can say in HR, human resource development, we can say in ERP, enterprise resource planning management system. In health sector also, we used to use artificial intelligence. So most of the decision, most of the agents, and most of the products will be based on the artificial intelligence by 2025. And you can say now we have been started this like era. So now we are moving towards the very, very strong AI era. So whether we should move towards that era, what precautions we should take whenever we are moving towards that era, what characteristic and what learning we should adopt when we are moving towards that era, that we supposed to consider. So now I'm going to start my presentation, which is first, what is the artificial intelligence? So a very beautiful quote is, artificial intelligence is a technology using which we can create intelligent system that can simulate human intelligence. So the goal, what is the goal behind this artificial? See, in layman term, if I talk about the artificial intelligence, means we are making the machine intelligent artificially. So that is the artificial intelligence, right? So goal, what is the goal behind this purpose? Actually, we want to achieve some cognitive skills. Now, what do you mean? What actually mean by the cognitive skills? Means we want to make our machine learn in such a way that they can think like human thinking. They can perform the task based on the human reasoning skills. So actually, this is the artificial intelligence. The goal behind the artificial intelligence is that we want to make the machines learn so that they can think they can think like human beings. So basically, if we are talking about artificial intelligence, we are not talking about the living beings. We are not talking about the plants. We are not talking about human. We are not talking about, say, animals. We are talking about only machines. This knowledge which we are providing artificially, this will be given to only machines. So this is the concept of artificial intelligence. So AI is everywhere. Wherever we will see now, the AI is everywhere, because AI we are using in health sector, AI we are using in transport. Health sector means how we can using artificial intelligence in health sector. See, if there is any query, you can ask. Okay, right. So basically, artificial intelligence, how we are using it in the health sector, we are actually we are actually creating various systems that can capture the symptom of the patients, and then they are providing the diagnosis. They are providing the predictions. Those systems provide the predictions based on the symptoms representation of that particular patient. So artificial intelligence we are using in healthcare sector, artificial intelligence we are using in agriculture to predict the nature of that particular soil, to predict the nature of the pesticide that we should use, to predict the various interest of the various customer in living in that particular area. So even agriculture, there is a huge scope of artificial intelligence. In education sector, we are using artificial intelligence because we are capturing the interest of our students, in which subject they actually want to learn, get the knowledge in which particular area. So we have not reached to that state that robots are educating them, because it is really not feasible. They can't replace the teachers, they can't replace the educators. But yes, we are moving towards that era also. So somehow some day-to-day task which a teacher used to do, which an educator used to do, some repetitive task that can be done by the robot also. So we are moving towards that era also. So artificial intelligence is everywhere. If we start from our home, like we are using Alexa, we are using home automation system, we are using various sensor devices in our homes. So till to the expert system. So artificial intelligence is everywhere. So these are the various application areas of AI. Now we are coming to various major techniques. So if I divide artificial intelligence in broad category, these are of two types. One is the logic and rule based, and other is the machine learning based. Right now, logic and rule based, basically these are the deterministic approaches. you can say these are the problem specific approaches. They are used to find a solution for a single problem statement, not for a general problem statement. So that's why deterministic approaches, actually they are based on if then else type of rules. I'll show you in the next slide. So these are the system like the which are following this approach, deterministic. Here we are using a knowledge base and we have some database. So based on these knowledge, actually we used to give into the system, we used to feed into the system before we want to predict something. So these basically deterministic approaches are based on the algorithm rather than the algorithm based on the data. These are based on the if then else type of the algorithms. So logic based techniques can't be generalized. So these are very rigid type of the you can say techniques of artificial intelligence. Now second category we have machine learning based, which are actually pattern learning based, or we can say that these are the probabilistic techniques that uses the concept of probability distributions. Now see, the techniques which are based on probability distribution, basically they incorporates the randomness. Actually, they incorporates the random variables in the problem statement, and they incorporates the probability distribution in their problem statement. So basically, they are well equipped, and they are we can say they are well. Uh, they are well trained to handle the various type of risk or various type of uncertainty that can occur in our business. So that's why in today's world we are using machine learning approach rather than the logic and rule based approaches, because they are able to handle uncertainty and the various risks that can come. So this was all about the logic base. So in today's session, because the need, or you can say need of today's business is machine learning approaches which are pattern based. So I'm going to talk about more about machine learning based approaches. So what actually machine learning is? So we can say that machine learning basically is a subset of artificial intelligence, right? Now, subset of artificial intelligence means what? Like in machine learning, basically we used to use data, and based on the data we develop the algorithm, and when we develop the algorithm, then we trained our machine to perform certain kind of decisions, certain kind of prediction, certain kind of reasoning. So that's why it is, we can say that machine learning is a subset of the artificial intelligence, right? So that's why it is a branch of AI that concerned with the design and development of algorithm that allow computers to evolve behavior based on empirical data. As intelligence requires knowledge, it is necessary for the computers to acquire knowledge. Now, how this knowledge can be provided, that we will cover by using the various machine learning techniques. Now, earlier approaches that we were using, in that case, computer has to perform on the data, but yes, with the help of the program, and then it shows the output. But in today's approaches, while we are using machine learning, computer used to perform on the data. What type of what type of task computer actually used to perform? Basically, it learned from the data, right? And then we have also the output, and as it learned from the data, it tells us from this data what kind of the output can be there that already we have in our data set. So it tells, or it converts it into the various programs. So basically logics are to be developed with the help of the data and the output, rather than traditionally we were using data, and then we were using various programs that operates on that particular data to give that particular output. But now the approach has been completely changed. So this is the machine learning era. Now, what actually our understanding related to machine learning? Basically, we are automating the various automation things. So this is the machine learning, getting computers to program themselves. Now, computer, because we are providing them data in the form of the input and in the form of the output. So computer itself can be programmed by using that particular data. Earlier, writing the software was a very big problem. It was a huge problem. So now, because we have huge amount of data, as per the latest survey, we used to like view. We used to download approximate 5 millions of data every day from YouTube. So you can easily, this is the downloading content. So you can imagine viewing content, how much larger it will be. So we have huge amount of the data, and if we are not able to learn how to use that particular data, we are illiterate person in today's era. So this is the thing that machine learning focusing, that how to use that particular data so that we can train our machines artificially. So whenever we are talking about the machine learning, basically we used to talk about supervised learning, unsupervised learning, various type of terms that come under with the machine learning concepts. So I will be taking one by one. Firstly, I am switching to supervised and unsupervised learning. And under this supervised and unsupervised learning, I'll be considering few terms. So if we are talking about machine learning, means we are talking about supervised and unsupervised learning, because we are providing some learning to some particular machine, right? Now, what are understanding related to this supervised learning? See, supervised learning, if I talk about, basically this is the learning that we provide to a machine in the supervision of something. Now, what that something is, for example, we are providing some data to a machine, and in that data, we have some input and we have some output. Now, output means I am talking about labels, right? Output means I am talking about the dependent variables. Input means I am talking about the independent variables. Input means I'm talking about the features rather than the labels, right? So means supervise, why we are using the term supervise over here? Because we have something based on which we are making the machines learn. And what that something is our output. That something is our labeling. So that's why we are learning the various machines under the concept of supervision, right? Now, unsupervised learning techniques are, what are those techniques? We are providing knowledge, we are providing learning to the machines, but there is no supervision. Means I can't say that there is no output, but yes, I will say there is no labeling, there is no target variable. We are supposed to find those target variables. We are supposed to find those variables which are telling me this will be the output of that particular system. So that is the unsupervised learning, right? So basically, whenever we are talking about the machine learning, these are the various terms that we will be using: supervised, unsupervised, feature extraction, and grouping of the objects, predictive model, annotated data, new data, like these training data set, testing data set. We'll be using these terms whenever we will talking about the machine learning algorithms or machine learning concept. So firstly, I have discussed about the supervised and unsupervised learning. Then I'll be discussing just this is the brief introduction of these two. Then I'll be switching to the detailed description also. Now, what actually reinforcement learning is? Before I switch to this reinforcement learning, first I will cover the various types of supervised learning. So for now, I am leaving this concept over here, so that first we will cover classification, and then I will tell you what is the reinforcement learning is. So whenever we are talking about the machine learning algorithm, or whenever we are talking about machine learning concept, so there are three components that actually we used to use. One is representation, evaluation, and optimization. So as my specialization area is also a particle SWAM optimization. So optimization means, see, we are generating the algorithm, but in a very optimized way. In layman term, we can understand like that way, right? Representation means as we are providing knowledge to a particular machine, so there must be some model, there must be some representative methods, so that that machine can give the output. Evaluation means whatever we are going to create, that must be evaluated on some parameters or some metric. So whenever we are talking about a machine learning algorithm, we talk about model, We talk about metrics that actually judge the performance, that actually find the performance of that particular model. And then optimization means if there is need to do the optimization, means if it is not behaving, it is not giving the result as per our requirement, then what are the various further optimization techniques that we can use in machine learning. So performance, whenever we talk about the performance of machine learning algorithm, there is the concept of various matrices that we'll be using. For example, we can measure accuracy, we can measure fault rate, we can measure like sensitivity, we can measure specificity, or everything we will be discussing. But everything it depends upon its background knowledge and depending upon the training data set that we are actually using. So how it measure the performance, that we'll cover later on. So these are the various terms that machine learning concept uses: clustering, unsupervised learning, supervised learning, regression, everything we'll be discussing, but not in the detail. Yes, now this is the machine learning means we have divided the machine learning concept, or you can say this learning concept into two you can say techniques. One is the supervised, another is unsupervised. In supervised, basic definition I earlier told you, but yes, in supervised we have regression and the classification, and in unsupervised we have clustering and many more. Association also is there in unsupervised learning. Now, what actually classification and regression means? See, basically, as I mentioned, that in supervised learning, actually we give something to the machine so that machine can learn. Right now, whenever we are providing the information to that particular machine, that is in the form of the output or in the form of the labeling. Right now, but it depends upon the data, what kind of data actually we are using. For example, if we have categorical data, for example, if I'm using whether today there is I can say whether there is windy weather or not, there is sunny weather or not, then what are the chances of raining in by the evening. So this is the concept of the classification. Why? Because here we are using the categorical data, right? Whenever we are making the prediction based on the continuous data, or whenever we are making the prediction based on the real data by using some statistical methods, then that is the regression. But when we are making the prediction based on the model, and whenever we are making the prediction based on the categorical data, then this is the classification. Basically, we are classifying them. And regression means we are using the concept of the statistics analysis, which is the maths concept. So to make the machine learn. Now, unsupervised learning, we used to use a major term, which is the clustering. See, clustering is also, we can say, as the name suggests, we are grouping the various items together into a single unit, right? Now, because we are making the groups of those particular items, now those particular items should be related in some manner, so that we are dividing them in the various groups. For example, we have 100 records, 100 tuples we have. Now I want to create two groups of these 100 tuples. Say we can say 50-50 if for now we are assuming that 50 rows ka we want to create a group. Then there must be some similarity among those 50 members so that I can create a single group. Right? For example, whenever students take admission in our college, so we used to divide them into various sections. So there must be some similarity. For example, their name are starting from A to D there, so that we can divide them in section A. Their name are from like E to G, then I can give them a section, I can assign them a section B. So there must be some similarity criteria. Now, what actually that similarity criteria is, that depends upon algorithm to algorithm. Usually we used to take the distance. Now, distance from where, that we will cover whenever we will discussing about the clustering. But yes, some similarity measure we are supposed to consider, so that we can divide them into the various clusters. So these are the concepts of supervised and unsupervised learning. Yes. Now, whenever we are talking about these concepts, we have to come across these various basic terminologies, which are the classify, classification, model, feature, and say binary classification, multi class classification. There are various terminology we used to use. Now, what are those terminologies? So first of all, a classifier, an algorithm that maps the input data to specific category. As I mentioned you, that we used to whenever you are dealing with the categorical data, and we have some input, we have some features, and against those inputs we have some outputs, we have some target variable, or you can say we have some dependent variable. So there must be some model, or there must be some algorithm, or there must be some way that actually classify, that actually map those input and output variable, right? So this is the classifier concept of classifier and the classification model. Feature, as I already mentioned, these are the some independent variables or some phenomena or some property that we are considering for this developing of this model. Now, a binary classification means, for example, we are dividing the data into the two classes. Binary means 0 or 1, means 2. So we are dividing the data into the two classes. For example, if the patient has these symptoms, then whether that patient is suffering from that particular disease or not, either will be getting the answer either yes or no, right? We have some like you can say the type of that particular soil. If that soil is say red, then there is a presence of that particular chemical or not. So we have the answer either in yes or no. So that is the binary classification whenever we are providing only two classes to the target variable to the output, then that is the binary classification. But yes, if we have type of the target variable in such a way that we can provide them multiple classes, for example 0, 1, 2, for example height, right? You can measure the height in such a way that height can be medium, height can be like very less height, or height can be high. So like that way, if we are taking a survey of the various customers, some customer will be strongly agreed, some customer will be say you can say simply agreed, some customer will be medium agreed. So like that way, some customer will be highly strongly agreed. So there are the multiple classes. Then in that case, this can be think as sort of multi-classes example, right? So now a classification, whenever we are talking about the classification, which is the type of the supervised learning, whenever we are talking about the classification means we are talking about the training and the testing data, right? Now, for example, I am considering some sample data, and that sample data we have 100 records. Now, usually what we used to do, 2/3 of those records we used to use as a training data set, and then 1/3 of that particular data set we used to use as a testing data set. Now, training data set means we are like creating our model based on that particular data set, which is actually acting as a input for us. So that we can say means input, we build the model around this training data set, around the 2/3 of that particular data set, and then we test the model around that 1/3 of that particular data set. So like that way we used to use classification approaches. So it is a two-step process, classification, which is one is the model generation, another is the performance evaluation. Now, because as I mentioned you, this is the performance evaluation. So performance evaluation can be done in the various ways. For example, we can use confusion metrics. We can use various other metrics. Now, what are those metrics and what are their result for that particular class? What result can be provided by these matrices? That we will cover when we will cover the decision tree algorithm, right? So now I'm just directly switching to the decision tree. So we have various version of decision tree. Basically, we have like a card decision tree, ID3 decision tree, because we are doing the implementation. So I'm just starting with the very basic version of decision tree, which is the ID3. Usually we used to use this decision tree. Now, decision tree is one of the type of the classification. There are various type of the algorithm we have to whenever we want to classify the data. As I earlier mentioned you, classification whenever we are using some categorical type of the data, right? See, whenever I am talking about the categorical type of the data, I am talking about the target variable, right? Now means in the output we will get some categorical type of the data. If in the output we are getting some values, then that we will be using regression. If in the output we are getting some categorical type of the data, then we will be using decision tree, right? So decision tree basically it provide us some rules. Now these rules are based on the various criteria, right? Now various criteria, what are the various criterias? For example, very a simple example have been considered over here, that this age, based on this age parameter, whether that age is less than or equal to 30 or greater than 30 or between 30 to 40, a person like to buy a particular computer or not. So based on this parameter age, say if it is age is less than equal to 30, then we are checking whether that person is student or some employer or like that category we are checking. If that is student, definitely student has to buy the computer, because in today's era everything is happening virtually. So yes, of course today though everyone is buying computer. But yes, this is the very simple example, right? If the person is not a student, then no need to buy that particular computer. So like the same way, if the age is between 30 to 40, definitely that person would like to buy that particular computer system. So like that way, based on the input, based on the input variables, based on the independent variables, we are actually generating some rules by using the decision tree, which is the tree-like structure, and which used to use the splitting approaches to split the input variables in a tree-like structure to provide us some rules. Right. So this is the basically decision tree algorithm. Now in decision tree algorithm, we used to use two terms. One is the entropy. Basically entropy is actually used in everywhere further. So entropy means how you can it actually judge the randomness in your data, right? So if we are its value actually lie between 0 to 1. Now if all the members, if its value is 0, means it's all the members, they belong to the same class. So basically entropy we used to use to measure the randomness in the nature of the particular variables, right? So now to consider this example, this is the scenario which is given to us. Now this scenario is telling us what we have various characteristic of the various animals. For example, we have ostrich, we have crocodile, we have like these animals we have, right? And these are the characteristic of these animals. Now whether these animal are warm-blooded, these animal have feather, these animal have fur or swims like that way. Now based on these characteristic, or you can say based
Ma'am,
on,
sorry to interrupt you. Your PPT is not visible right now.
okay, just give me a minute.
Okay, ma'am.
Ma'am, first you can stop sharing and then sharing again. Yes, ma'am. Now your
No.
PPT is visible, ma'am.
Okay, right. Thank you very much. Thank you. Okay, so we were talking about the this is our, you can say, data set, and in this data set we have the category of the various animals, and their category depends upon the various features, and these features are whether that those animals are warm-blooded, they have feather or not, they have fur or not, like they can swim or not. So based on that we are getting some output, that is whether they can lay the eggs or not, like crocodile, yes, based on these features. So this is the data set that we have been given. Right now in this data set, some tuples we consider as a training data set and some tuples we consider as a testing data set. So based on the training data set we used to develop that particular model, and based on the testing data set we used to test that particular model, the accuracy of that model. For this instance, I am considering all these tuples as a training data set. I am considering all these tuples to build the model. Now I am building this model by using decision tree algorithm. So here I am using the concept of entropy and information gain. Now entropy means, as I already mentioned you, that it represents the randomness of those particular those particular attributes. Right now, to calculate the entropy, the formula that we used to use, pi log to pi, right, minus pi log to pi. Now what does it means? P means here, once see, there must be some positive values and there must be some negative values in the data set. Now what are those positive values? Positive values means that are actually of my concern, that are actually of my interest. For example, I want to identify whether that particular animal can lay egg or not. So yes, if I'm saying that I want as many of cases yes, then that is of my interest. So yes category I'll consider as the positive tuple. No category I'll be considering as the negative tuple if I'm interested in finding the yes value for those particular animals, right? So for that, how we can calculate the entropy? See, first I'm going to divide these tuples into the positive and the negative value, and then I will find the entropy for the whole system. Now here in the final target variable, I am getting 4 yes class and 2 no classes, right? So that's why here the positive value means for the 4y means we have 4 yes and 2 no. So that's why the formula will become like that way, 4 divided by 6 log 2, 4 divided by 6 minus. Now 2 is for the no, so that's why this will give me the complete entropy for my system. Now, once I'll identify this complete entropy, this entropy I'll be using for finding the gain. Right now, whenever I used to find out the gain means information gains, means if we have low randomness in my nature, then that attribute will be of my interest. So low randomness means its entropy should be low, right? So how I can find the information gain? And why there is need to find out the information gain? Because whenever I want to make this tree like structure, first of all, I should have some attribute that I can consider as a root node, and further I should have some other attributes that further I can consider for splitting those particular uh, attributes, right? So that's why there is a need of some concept. And here we are using the concept of information gain, which is based on the entropy for splitting those particular attributes, and for deciding which attribute we should consider on the root as a root node on the top of the hierarchy. Now I will find I have these attributes: warm-blooded, feathers, fur, and swim. I will find out the information gain for all these attributes. Right now, how to find the information gain? First of all, for each and every, for individual attribute, I will identify all the yes and no classes, right? So for example, here for the warm-blooded, for how many yes we are getting here yes. So there are, this is the yes for which I am getting yes, this is the yes for which I am getting, so there are 3 yes for which I am getting yes, right? So that's why for the warm blooded we have 3 yes. right? Now total we have 4 yes and 2 no, for which we have find the we already have found the entropy. Now I am because taking the warm-blooded animal individually, so for that I need to find out its true positive value and its true negative value, right? Now for how many yes I'm getting no over here, so this is the yes, here I am getting no, and this is the yes, here I am getting no. So that's why for SES, which is the entropy I am taking here, for SES, I am taking here according to the data, there are 3 yes and 2 no, right? So this will give me, by applying the same formula which we have used over here, this will give me the entropy of 0.97095, right? Now the same way I will use for no, right? For no, now this is the no over here, right? So for no also we are getting one yes. Why one yes? Because just a minute. Yes, for no we are getting over here one yes and 0 no. So that's why, because here we have 1 0 no, so that's why means our entropy will become over here is 0, all the members that those belong to the same class. So whenever I used to find the this gain value, the formula to find the gain value is, first I will consider the overall system entropy, which is the this one 0.91829, and then I will use these entropy as the to get the final information gain. So in this case we have total 5 cases of yes and no, right? So that's why 5 divided by 6 into its entropy value is coming out 0.97095 plus, now here we are getting only one case, because 1 plus 0, one case of yes and no, and but yes there are total instances 6, so that's why 1 divided by 6, this term will become negative 0. So this will be the final answer. So like that way we will find the gain. Now whatever attribute have the largest value of the gain, in that case that attribute will be selected as a splitting node. So like that way we have found the gain of warm-blooded. We will find the gain of feathers also, and the other attribute also, and for which the value is coming out the maximum, that attribute will be selected as a splitting node, right? So initial node select will be selected by using this criteria. Further also, now if we want to move downward in the hierarchy, the same concept we will be using. We will be finding the information gain for all the attribute, and for which attribute it is coming out the maximum value, that will be selected as a splitting criteria, right? So like that way in the end we will get this tree. Okay, we will stop this splitting nature whenever we will get the value for which entropy is 0. For example, here we are getting only one class, so where there is no, then means that is fulfilling our criteria, right? So that's why this will be the final tree generation. Okay, now let's do its implementation using Python. Is there any doubt, any question till here? Can we proceed further? Yes, please tell me.
If you have any questions, you can message this in a message chat.
Yes, or dear participants, if you have any query, please raise your hand.
Theoretical aspect, if you have any doubt, you can ask right now.
Yes, I can see 2 hands. Yeah, please, you can type, or you can. Yes, Miss Vandana, I think you have some question.
No, sir said to raise hand if you do not have a question, so we do not have a question.
None.
Right. Okay, okay, right. So,
Ma'am, I think.
just I'm going to share my screen. Is my screen visible?
Right now it is not visible. Yes,
Okay.
it is.
Okay, right. It is
Ma'am,
visible.
excuse me, ma'am.
Yes.
There's a question from a participant.
Ye-
The concept of entropy, please explain again.
Okay, right.
Concept of entropy, ma'am.
Okay, right. See, I'm considering one more example. Just give me a minute, right? So that you can get the better understanding. Is my screen visible?
Yes, ma'am.
Okay, right.
It is visible.
Okay, right. See, we have this data set, right? Okay. Now, in this data set, we have the detail of various person, whether they are male or female, right? And based on some characteristics, based on some variables, which are the hair length, weight, and age, we are classifying them male or female. So, see, this is the data set that we have been provided, right? Now, I'm making my machine to learn. Means if that person hair length is like this way, weight is like this way, and age is like that way, then that person is classified as male. That person is classified as female if the value of hair length is this and weight is this and age is this, right? Now I want to check if there is a person comic, his or her weight is 8 and sorry, weight is 290 and the say hair length is 8 and value of age is 38, then I am supposed to classify whether that person is male or female, right? So for that, in case of decision tree, I'll be using the concept of entropy, right? Now again, I am finding the entropy by considering this example so that you must have the better understanding. Now, in this case, the same formula we are going to apply. We are first supposed to find out the positive values and the negative values in my data set, right? Now, in this data set, see how many males and females we have. Say 1, 2, 3, 4, 5. We have 5 males. 1, 2, 3, 4, 5. We have 5 females, right? The value, just a minute. 1, 2, 3, 4. We have 4 females. 1, 2, 3, 4, 5. We have 5 male, right? So this is our data set. Okay. Now, for instance, I'm considering positive for female and negative for male, right? So this example is considering like that way. Now here positive for female and negative for male. Okay. Now in that case, we have, if I'm finding the entropy of my whole system, my complete system. So P value is 4, right? And N value is 5, right? The formula will be P divided by P plus N, right? Now, which is the P means positive and the total number of the cases, which are the 4 and 5. So that's why positive and negative total number of the cases are total 9. So 4 divided by 9 log 2, 4 divided by 9, you will get some value, right? Now here also now I am finding for the negative. Now 5 divided by 9 log 2, 5 divided by 9. This will give me the entropy, total entropy of my system. Okay, right. Now I want to select which attribute should be considered as a root node. Means which attribute should be considered as a splitting node. Okay. Now for the consideration of a splitting node, I am supposed to consider the concept of information gain. And for that information gain also, I'll be using the concept of entropy, right? Now, entropy, how I'll be using, I'll be putting this value in this formula. But yes, before that, there must be some range. See, here we are using continuous data. So it doesn't mean that we'll be using regression here. No, we will be using classification over here because the target variable I am getting that has the classes, that have the labels, right? So that's why I'll be using decision tree. I'll be using classification over here. Now, if I'm considering hair length as a root node, okay, for example, I'm considering hair length as a root node, right? Now, how I can select, I have to find these values that I'll be doing. Okay, now for the hair length, I'm taking the values, say, if it is less than equal to 5, there can be cases of yes or no, right? Now, what are those cases? See, for the yes, if its value is less than equal to 5, so if its value is less than equal to 5, we have this 0, we have this 2, we have this 1, right? So we have these 3. Why here we are writing 3 as a negative? Because all these are male. Okay, so I'm taking it as no value, right? Because earlier we have considered male as the no value. Okay, means negative value, right? Now for the value here, length is less than equal to 5. For the female scenario, for the female case, there is only this one value. Okay, right? So that's why for the positive case, I have only one value. So entropy for the hair length, where I am considering hair length less than equal to 5, will be 0.8113. Okay. Now, why? Because here this is the positive value and this is the negative value. So I will apply the same formula over here to get this value. Now for this scenario where this is no, again I will find the entropy over here by using the same formula. Okay. Now to find the gain of which attribute I am considering hair length only. So to find the gain over here, I'll be using entropy of the current set, which I have calculated earlier, which is 0.9911. And then I'll be using the entropy value of these children. For now, I have considered only one child, which is hair length, right? So for that, 4 divided by 9. Why here 4? Because this is the 4. 4 divided by 9, the scenario of the female over here, right? So 4 divided by 9, sorry, no. 4 divided, this scenario I am going to consider total, which is 4. And this scenario I am going to consider total 5. Okay, so into 0.8113. Here it will come out into 0.9710. So like that way, its gain is coming out 0.0911. Right? Like the same way, I will calculate the gain of the other children. Right? So in this case, I am finding gain of the weight. It is coming out 0.5900. Age, it is coming out 0.0183. So means highest value of the gain is for weight. So I'll be considering weight as the splitting node because we are considering it for the very first time. So it will be considered as a root node. So this is the concept of entropy and the information gain. I hope now it is clear.
Ma'am, there are certain questions which are typed out in the message box. I'll just read out them.
Yeah. Yes, please.
First question is, explain the transition from machine learning to decision tree.
Okay.
This has been asked by Kamal.
Right. Okay. See, machine learning means we are making the machine to learn something, right? So whenever you want to make some machine to learn for anything, that can be done in 2 ways. One is the supervised way and other is the unsupervised way. Right? Supervised way, whenever we are considering the example of supervised way, we are considering the example of classification, because supervised learning, we have broadly 2 categories. One is the classification and other is the regression. Right? Now, regression means we are considering the statistical methods, which are based on the math statistics. We are considering the statistical methods to map output variable with the input variable, to map dependent variable with the independent variable, right? For whenever we have continuous data in our output, then we used to use regression. Now, classification means we are actually developing a model to predict something, but that model will be based on what? That model will be based upon the nature of the type of that particular target variable or the output, which is the categorical. Okay, now whenever I am talking about the classification, means there must be some techniques, because I am considering classification as the technique of the supervised learning, where I'm making my machine to learn something in presence of something, and that presence of something means the labels. Label means, for example, we have considered here in this data set, we have these labels. Yes, no, no means output, means target variables. So these are the labels, right? So this is the concept of the classification. Now, whenever you are considering the classification, there are some algorithm to classify our data. In these algorithm, one of the algorithm is the decision tree. Now, in case of decision tree, we use the tree-like structure to generate the rules so that we can predict something, so that we can develop a model to get some knowledge for the prediction. So that is actually the transition from machine learning to decision tree.
Any more queries? I hope ma'am has cleared the doubts. If any doubts, you can type it on chat box, or you can raise your hands.
So shall we switch to Python
Yes.
implementation? Right.
Yes.
Okay. Okay. So is my screen visible?
Yes. Yes, ma'am.
Okay.
Jupyter, it is visible.
Yes. So if you all have like Anaconda version, then you can install Jupyter Notebook like this way. Otherwise, you can open Google Colab, whatever way you want to use, Python, whatever way you want to like implement that particular decision tree algorithm. I'm using Jupyter Notebook, right? So from here, I will launch that. And see, whenever we want to implement decision tree in Python, we are supposed to use few libraries, right? Now, these libraries are, as we are all are aware about the pandas. So we import pandas SPD. Then we will be using scikit, basically scikit library. And from that, we will import the decision tree classifier module, right? So this is the command to run that. From sklearn.tree, import decision tree classifier. So this is the module that we'll be using. Similarly, because we are supposed to train our data set and we are supposed to test our model also, then for that case, we will be using this train test split module. So we are supposed to import this as well. Right. Now, again, then because we'll be using some matrices, Abhi, I will let you know what matrices we'll be using. So we'll be using some matrices to calculate or to find the accuracy. So for that, I'll be using import matrix. Right. So for now, there must be some data set, right, for which you want to create some particular prediction model, right? So you can use any data set. If you have your own data set, then you can use it. I have this data set, which is a diabetes data set, and in this data set, what values I have, I just show you. This is the type of the data set, right? So I'll give the command. See, here you are supposed to specify the path of the file where actually it is saved. So I'll be using read_csv method to read this particular file. Now, because I am specifying here path in Python, this is a special character. Underscore is a special character. So I'm supposed to specify it as a raw string over here. So I'll be using R before the start of the string, so that because in Python this this will be treated as a some special character, then it will cause some error. It will not read the file. So we have to specify this / 4 times. So this is the actually syntax in the Python. So whether you can use R to specify it as a raw string, so it will treat it as a raw string and it will read this file. So whenever I will read this file, I'll display the content, its heads, all its value if I want to display them. So it will show like this way. So this is my data set. There are a huge number of tuples. For now, it is showing just only this data set. These many tuples it is showing, right? Now, till now, we have imported some libraries and we load our data set. Okay. Now, what actually next is, I want to consider the concept of splitting of those particular attributes. Now, if I want to use the concept of splitting, first of all, I need to decide which attributes I'll be using as the dependent and which attributes I'll be using as the independent variable. So independent variable means I have some features that will be treating as a input variable. So these are the feature columns that I'm considering, which is this pregnant, glucose, BP value, skin value, like that way. So these attributes I'm taking as the input variable. So I'm going to define them as a feature columns. Now this is the value, this is the label that I'm going to define as a label, means class, means output, means target variable. So that's why X will be this is the name of the data set. Say it is given over here. Any name you can take. I have stored this data set into this schema. So you can any name you can use over here. So in this feature columns, these are the columns that I am saving their value in X. Label I am saving their value in Y. Right now for X we have some training and testing data set. Again for Y we have some training and testing data set. For example, now see this this is my data set and this is the data set, right? So in X I have name here, height, weight and lotion. In Y I have sunburn, right? So means if my name is name like that way, here height, weight, lotion, based on that I'm predicting that whether that particular person is suffering from sunburn or not. So I have two classes over here, yes and no. I can have multiple classes over here also, but for now I am considering it binary classification. So that's why we have only two classes over here, right? So now X, in X also we have some training data set and testing data set, because I told you if we have 1000 of tuples, then 2/3 of those tuples will be considered as a training data set and rest will be considered as the testing data set. Similarly, Y also we have some training and testing data set, right? So here we have in this X also we have some training and we have some testing data set. Y also we have some training and testing data set. I'll be using this train test split method. In this method, I'll be passing the splitting of that particular data into training and testing. Plus, I will specify the size. For example, here if I have specified 0.3, then it means that 70% will be treated as a training and 30% will be treated as a testing. Random state is equal to 1 means you are initializing. It will be treated as a randomly. Right. So these are the parameters that we are supposed to pass whenever we are taking this train test splitting method. Right. Now you can print these values. For now, I have just given the make it as a comment. So now I'll be calling decision tree classifier by using this decision tree classifier method. So I am saving this value in CLF. Now once I have called this decision tree classifier, then I will fit this tree classifier. Fit means now I have started the training, right? So in this case, X train and Y train, because I have started the training. Okay, once I will fit, then the next task is to predict. I will check for the response. So that's why here Y predict will be depends upon the X predict. For the training, I'll be using both X and Y. But for the predicting, because I have to predict this value, so that's why I will considering the passing the parameter only X, right? So when I will print this value, it will classify that particular data into these classes. So it's very simple in Python, because in Python we have a lot of libraries that we can use. So implementation of these various algorithms, say you are talking about decision tree algorithm, you are talking about say clustering any algorithm, or you are talking about handling with the missing values, which is the part of the pre-processing. If I will try to cover that also. So we can, these are very simple to implement in case of Python, right? So like this way we can implement. And yes, now if you want to check the accuracy, so for that we must have the understanding of the various metrics that we can use for the accuracy. I will explain only one, rest you can read by your own. But yes, if any doubt, then you can ask. So because there is a time limit, it's already 11:10, so now I will move a little bit fast. Yes, so the evaluation measures, or the metrics that we use to measure the accuracy of that particular decision tree implementation, we can use various matrices. One of them is the confusion matrix, right? For this confusion matrix, we are supposed to find out the various values which are the true positive, true negative, false positive, and false negative, right? Now, what are these terms? See, a true positive means that the value of the actual class is yes, and the value of the predicted class is also yes, right? If you have developed some model by considering the training data set, so in training data set, its value is yes, and whatever you predicted, right, that's also is yes. So that is the true positive. Now true negative means which is actually truly negatively predicted, so that is true negative. False positive means its actual class value is no, but it is predicted falsely positive. So that is the false positive. Whenever it is predicted falsely negative, then it is the false negative. So the formula to calculate the accuracy is TP plus TN, which is true positive plus true negative, divided by P plus N, which is the positive and the total negative. Now, how we can find that? See, for example, this is the scenario which is given, that particular person will buy that computer or not. So we have two classes, yes or no, right? Now, this is the actual class value, yes and no. Now, for the predicted class value, it is coming out 6954 and it is coming out 46. For example, it is coming out here 412 and this. Now, total instances for this yes and no over here are 7000. So if I'll say the recognition for this particular yes scenario, then it is 99.34%. Now for the no scenario, it is 86.23 from this. Now, whenever I want to find out the accuracy measure, see, its value is here, yes, and it is predicted yes. In what sample, what is the value of the sample for which it is predicted truly positive? 6954 samples are there for which it is predicted truly positive, right? So its value is 6954 for true positive. Now, for the prediction of truly negative, its value is 2588. So I will add these two values divided by total number of samples are 10,000. So its accuracy will coming out 95.42. So in Python, accuracy is measured by using this accuracy score. So this library we have imported over here. This one, import matrix, and now here we are using this score, right? So now, because we are supposed to find out the score for the Y test and for the predicted, whatever you have performed the testing and whatever you have, the prediction has been shown over here. So its accuracy is coming out 67%, right? Now, you can change the parameter of decision tree as well, because we have the various criteria. You can use Gini index like the entropy. One of the method to split the node is entropy. One of the method is you can use Gini index. One of the method we can use information gain. So there are various methods for splitting of the nodes, right? So you can change that particular criteria by specifying over here. For example, the accuracy in case of the Gini index, it was 67%. By default, it will be Gini index will be taken. Now, whenever I am specifying the entropy here, I can specify the depth also by considering here I have not specified anything. So it is taking it as by default decision tree classifier method I have used over here. So I'm not passing any parameter. If it is taking by default, so by default it is taking in Gini index and depth till the actual result. Now here I can specify the depth also. See, there are various other criteria why we use this concept maximum depth or minimum depth, because we have to means avoid overfitting and underfitting concept also. Now what are those means? Whenever you are actually dividing splitting the attributes to the maximum level, then that tree will go overfit. So we are supposed to avoid all these circumstances. So like that way, maximum depth we can specify, criteria we can specify, and then its accuracy. See, its accuracy is coming out 77%. So like that way, you can change as per your requirement, as per your algorithm. If you are using in your research work, you are using entropy, then you can specify over here. If you are using accuracy matrix, you can specify here accuracy score. If you are using precision score in your research work, then you can specify precision score method over here. If you are using recall, then you can use precision recall over here. You can just, by using recall curve, you can just print the curve also. So simply we are supposed to use the various import libraries, and there are various methods if you want to implement them in the Python. It's very easy to implement actually. So this was all about the decision tree. Now I am directly switching to the clustering algorithm. For that, see, as I mentioned that clustering means unsupervised learning. Okay. Right. Unsupervised learning. Okay. Means we are actually going to form the various clusters based on some similarity measure. Right. Now we have this sample data set. Okay. Now I am going to divide these data into the various clusters. Now, what is that similarity measure? That similarity measure, I am considering the distance from a particular point, a distance of all these particles from a particular point. Now, what that particular point is, in case of k-means algorithm, in case of k-means clustering algorithm, that point is centroid. You are supposed to consider any two random point, right, in the beginning of that particular algorithm. So for example, that can be out of your data set also. There is no need to consider those data points from your data set only. You can consider them out of your data set. So first of all, I'll be considering few points. For example, these 2 points I have considered. Right. Now I will measure the distance of each and every particle from these 2 points. Okay. Now whatever the particle comes near to this particular point, I will create a cluster of this particle. If any particle is near to this red particle, then I will create the another cluster. So like that way, I will arrange all the particles depending upon the distance from these 2 points. So these 2 clusters will be formed. This process will be repeated by using covariance of those particular centroids. These are the centroids basically, right? So by considering the covariance of those particular centroids, this is the iterative algorithm. Unless until our maximum limitation, our maximum threshold value have been reached, This is the criteria that we are supposed to decide for our clustering algorithm. When you want to, stopping criteria is very important thing whenever you are performing a research. So when you want to stop your algorithm, sometimes we can specify the iteration, say maximum iteration I want to perform 10 iteration, or maximum iteration, for example, I want to perform say 20 iteration. Or you can specify your criteria for the stopping, some threshold value you can specify, or you can specify when this value will again come similar to the previous value, then that algorithm will stop over there. So in clustering algorithm, what actually we used to do, we used to make the cluster based on the similarity measure, and that similarity measure we are considering the distance among the various points. Now what that distance is, to calculate that distance is, we are using the Euclidean distance formula. Okay, so this was all about the clustering algorithm. Now if you want to implement that clustering algorithm in your own data set, then how we can do that? Just give me a minute so that I can download and those notebooks. Yes. I hope my screen is visible to everyone.
Yes, ma'am, it is visible.
Okay, okay, right. So whenever you want to implement clustering algorithm, see in the previous example, we have considered some data set that we have downloaded from the internet, or you have your own data set. Now we can generate the data set as well in our algorithm or in our implementation. So again, we are supposed to import this NumPy library, matplot. This is depending upon whether you want to visualize your result or not. So yes, scikit we are supposed to use. So sklearn.cluster import k-means, whatever method you want to use, clustering method, clustering algorithm you want to use, that you are supposed to specify over here. Right now, first we are generating the data set. Okay, now in k-means clustering algorithm, because what we are considering, actually here we are generating the random samples from the multivariate normal distribution. So that's why I'm using these term random.multivariate underscore normal. So it depends upon your data set, whatever data set you want to use, that you can choose. Basically, as we all know, multivariate normal distribution, basically it is the or you can say Gaussian distribution is a generalized form of the one-dimensional normal distribution to the higher level, higher dimensions, right? So basically I'm using these method over here, multivariate normal distributions, right? So here T is representing the transpose. Here I am specifying the covariance, because it will be using the covariance k-means method. You are supposed to specify the covariance. Initially you are supposed to specify. So because this algorithm will work on the k-variance, covariance, right? K means, one thing I forgot to tell you, K means here cluster, total number of the cluster, K means, right? K, just K means, right? Not means. Okay, so K, meaning of K is the total number of the cluster that you are using. Suppose I am using 2 cluster, so 2 means. If I am using 3 clusters, so 3 means, like that way. So here I have generated the data set. Just I want to visualize it ki initially before clustering how my data set actually appears. So it is like that way. So I have just plot a graph over here and then show that particular graph. So by using these methods. So now I am going to apply the k-means model, right? Whenever you want to apply the k-means model, you are supposed to first zip your data. This is the very important thing. You are supposed to first zip your data into a single NumPy array. So this is the requirement whenever you want to implement k-means algorithm in Python, right? So now first task will be, I will specify the total number of the cluster. Here I have specified the total number of 2 clusters, right? Now, whenever I have specified the cluster, now I am going to develop my model. So I will use the fit method. Whenever you start the development of your particular model based on the training data set, so here I'm not using training and testing, right? So because here we have been provided some data that I am taking as dependent and independent variables, right? So but yes, here dependent variables are not known at the earlier stage. We are supposed to find out in clustering. Okay, so that's why I am going to generate the model. I'll be using fit method. Now x is what? X is my total number of the members, elements of that particular array. So this is my x, which I have generated by using these methods. These actually you can use any method. You can use your own data set also. No need to go in the complex detail of the complexity of that particular data set. So you can, as per your requirement, you can create. So yes. So once I will fit that particular data, then the next is I'll find out the centroids, right? And then I will assign the labels, okay, right? By using this algorithm, okay? Now, if I want to check their values, so these are my labels. These are my actually cluster. For example, here I am changing the value of the cluster. Say I use it over 3 over here. I need to implement everything once again so that it can show me the side by side. I will send you this Jupyter notebook so that you can implement it. So you can simply just give the command shift press enter and you will be able to see the result over here. So I'm just running it and each and every cell I am running it, executing this cell. And here I have changed the cluster from 2 to 3. So now when I will fit my model and then the values will be changed. See, over here you are looking 0 and 1. Then there will be the formation of the third cluster also. So 0, 1 and 2 like that way. And the value of the centroid will also be changed because it's the iterative method. So it will iterate until it reach to the stopping criteria. So if you want to visualize your cluster, you can use the various Python like libraries also. Scatter plot we can use, anything you can use. Like this way I have printed this result. So G is for green and R for red color you can specify. You can specify the marker size also by using passing these parameters. So whatever you want to take, like this way I can print my clusters. I can even compare my clusters also. Yes, this is the very important concept. In Python, we have Siloid score to to measure the efficiency of the cluster that I have generated, that I have designed. Now, Siloid score actually what it does, it find out some score between -1 to 1. Okay, initially its value is 0 we have specified, but some value will be calculated. So it ranges from -1 to 1. -1 means our cluster is densely clustered, our sample is densely clustered, and so that's why there is a very fine separation between the various clusters. So that cluster is the absolute very good, you can say very qualitative cluster. If its value is coming out near with around 0, then it's not in the best category, but yes, again it is a good cluster. But if its value is moving towards the 1 or it is reaches to 1, then there is some variable which is not clusterized appropriately, and cluster has been assigned wrongly. So like that way you can check the accuracy of your clustering method. So by using this Siloid score. So it's very easy to implement in Python Siloid score. You can simply import this module. Here, because we are taking minimum 2 cluster we are supposed to take, so that's why range is from 2 to k max plus 1. K max is the total maximum number of the iteration that you want to give over here. Because we are considering Python, so I am supposed to take plus 1 over here, which is the excluding, so it will run for 10 times. So like that way 10 times I will fit, I will make the clusters, and every time I'm printing the Siloid score. So this is my Siloid score, and you can just print its value, whatever you are getting in this Siloid score, you can just print that also. And this concept is a bit complex. Whenever you want to implement, you are supposed to memorize all these methods, because we are using Siloid module. So that's why how to implement it, it's inbuilt. Although it is inbuilt, we are just supposed to specify the logic behind that. So for example, here in the clustering range, I'm specifying that clusters total number of, this is the n clusters, is equal to n cluster dot fit, whatever you want to fit, right? So the result you will show like this way, this n clusters equal to 2, right? So yahan se this you will see is equal to 2 dot fit. हमने we actually develop the model over here. Label, we have assigned this to the label, means whether it belongs to 0 cluster, 1 cluster, 2 cluster, 3 cluster, like that way. So metric, because I am using Siloid score over here, so metric I am supposed to specify, I am using Euclidean. I can specify the sample size that I have specified 1000. My X value and my label means whatever cluster is it we have assigned, because we are now checking the accuracy. So whatever the cluster we have assigned, whether that is the appropriate one or not, for that I am calculating the score. So highest the score here will be the best the if the score is coming out, see the score is coming out around 0, so that's why I can say that this cluster is not in the, all these clusters are not in the best category, but yes, these are not also in the worst category. So why this 8th one is the better one? Because it is giving me 0.365648 result. Now there is some question why we are considering it the better one result. See, we have 58 also, we have 41 also. There is the concept of outliers. Whenever you are using the clustering algorithm, so you are supposed to consider the outliers also. So whenever the values are going beyond some range, you can't consider them. Usually it is assumed that that is the outlier. For example, if in your data set you are considering 50 records, and in 50 records, out of these 50 records, 30 records have the value from 1 to 10. Or you can say 40 records have the value from 1 to 10. But yes, remaining records have the value of 100. So in that case, those will be treated as the minority classes. And in case of clustering, those will be treated as the outliers, because they are going outside the classes, outside, you can say, the ranges. So that outside means there can be some negative also, there can be some positive also. It depends upon your data set. So this was the implementation of the clustering algorithm. And any doubt till now?
Thank you, Dr. Sujata, for delivering such an interesting and informative session on machine learning algorithms, where you covered a decision tree, K-means algorithm in depth, and also explained it through real-world examples on Jupyter Notebook. So I hope if you have any doubts, dear esteemed participants, you can raise your questions. You can type it on chat box, or else you can raise your hand. No questions?
So should I wind up the session then?
Kindly send PPT. They are asking for your PPT, ma'am.
Sure, I will send you. Then you can share with the participants.
Yes, ma'am. And
Okay.
a message I would like to read. Thank you, doctor, again for your rich presentation. Can you recommend readings, articles or books? Also interested on your contribution and current work of yours.
Yes, definitely. I'll be sharing all the data with all of you. I will share the data with Manjula ma'am, and Manjula ma'am will share with all of you, right? So I'm just winding up this session now, and because of the time limit, a lot of concepts still have left. I was planning to cover pre-processing of the data set, but not a problem. Some other time I'll try to cover. So now if see one concept that I want to mention over here, because we talk a lot about the machine learning, various terms now have been used in today's eras like machine learning and deep learning. So I will try to cover them firstly. Deep learning means there's a difference between machine learning and deep learning. Deep learning is the branch of machine learning, and machine learning is the branch of artificial intelligence, right? Now, whenever machine learning involves input, feature extraction, classification, and output. Now, this is done like we are supplying the input, and from that input we are extracting the features, and we are training or we are developing the model by using the classification or clustering or whatever machine learning algorithm you are using, and there will be the output. When this task is performed by the machine itself, then it becomes the deep learning. Feature extraction and classification, or any algorithm of machine learning. Here the term I have written classification. Any term you can, any algorithm or any machine learning technique you can use over here. If it is done by the machine itself, then it becomes the deep learning. So for example, see here, these are the very good example for the deep learning. So a man in the black shirt is playing a guitar. So feature is black shirt, right? And feature is man, it's not a female, it's a man, right? Or and other feature is it has some object, which is the guitar. So machine is able to identify all these features and then classify it. So this is the deep learning, right? Two young girls are playing with that particular toy. The boy is doing, say, some flip, back flip or front flip, whatever flip is he's going to do. So means we are extracting the features also by the machine. So it is the fastest growing segment of artificial intelligence. So this was all about the machine learning and deep learning. Basically, deep learning we used to implement by using neural network. So there is a lot to study about the deep learning because it's a very huge and wide area. So, but yes, focus area of machine learning and deep learning in today's environment where actually businesses are using these terms. So these are the focus areas, and basically enterprise resource planning, smart healthcare, business intelligence to provide the prediction, visualization and business insights, customer insights, virtual assistants. So like that way we can use. But yes, there are various limitations of artificial intelligence, and these limitations are with this. These limitation I can explain with this diagram. See, at present we are at this stage, artificial narrow intelligence, where man or human, you can say, that is much more better as compared to the machine. But yes, we are moving toward this scenario. We are moving towards this era, which is the artificial general intelligence era, where the power of the man and the machine will become somehow equal. And this is the hypothetical concept where the machine learning or the power of the or the artificially intelligent machines that will become the more powerful as compared to the man. So this is hypothetical concept. Till now we have achieved over here only. We are moving towards this era. So yes, whenever we are moving towards this era, we must taken care of the security, we must taken care of the various guidelines that a particular artificial intelligence technique should use. Because earlier you must have heard about that in the Facebook office, two machines started talking with themselves. So this was the scenario last year. It happened. So as we are moving in this era, so there must be some guidelines, there must be some ethics that we are supposed to follow and that we are supposed to introduce. So this was all about the artificial intelligence. I hope I made myself clear with these aspects.
Ma'am, there is a question that they are asking to share your research areas.
Okay, my research areas are basically I have used the concept of machine learning and artificial intelligence in software engineering applications. So basically my area is software engineering where I am using artificial intelligence.
Okay. And participants are also requesting for the Jupyter notebook, the program which you had executed in the
Sure.
Jupyter notebook.
Sure, I will share with you. Definitely.
Okay.
Okay.
Any other questions? Any other questions?
One question, ma'am. Ma'am, am
Yes,
I audible, ma'am?
Yes,
you
ma'am.
are
You are
audible.
audible.
Good morning, ma'am. Ma'am, my question is that whether large data set is applicable for deep learning. Ma'am,
Yes.
I know that deep learning is applicable only for large data set. Whether we can apply small data sets to the deep learning model, ma'am?
Yes, you can apply small data set also, because if you have small data set, you can generate dummy data set from that small data set. You can see the accuracy you can find only in the large data set, the accuracy of that particular algorithm. And whenever we are dealing with the neural networks where we are using the concept of the number of hidden layers, so the best efficiency of the algorithm will you will get only when there is a huge amount of the data. But yes, if you have some data, say you have 25 records, you can extend it by generating a random data set from that particular record, dummy data set. So that actually is sampling, yeah, that we can do.
Yes, yes. Thank you.
Any other queries?
Good afternoon, ma'am. Anuradha this side. Thanks
Hello,
for
ma'am.
obliging. Hello, ma'am. Thanks for obliging our request. It was a great presentation indeed. I just would like to know what are the various research areas where the faculty or MTech or research scholars can do their research work.
Right. In today's scenario, see, various industries are trying to find out to predict a model. Like, for example, as we know, this is the COVID pandemic scenario is going on. So after post-COVID scenario, a company, how many employees should a company allow to attend that particular office? So like that way, companies are working on that. We can also work over like in education also to find the interest or to find the pattern of some pattern of some concern of our students. Like for that, we can predict some model. So we can introduce various specialization courses according to that. So rather than taking the data manually, we are used to collect the data manually on the form. We can generate a model based on the classification and machine learning techniques. So that we can do. We can use everywhere machine learning, starting from our life when we used to get up early in the morning till the end of the day. You can use machine learning everywhere. See, for example, I was thinking how machine learning I can use so that to handle the various appliances at my home. So like that way, home automation system that you can use, it sends the body temperature, and our phone, our fans and our AC will regulate the temperature accordingly depending upon our body temperature. So again, this is the machine learning. So everywhere we can use machine learning.
Thank you, ma'am. Thank you so much.
Okay, thank you very much. Thank you.
Thank you, Dr. Sujata, for sharing your knowledge with us. Thank you so much. It was really very interesting session.
Thank you. Thank you.
Can I, एक minute, ma'am. Can I request participants to put on their video for a snap, please? Snap with our speaker.
अभी आएगा ना?
Manjula ma'am, I think we are done.
Okay, ma'am. Okay.
Okay. Thank you
Okay.
very much.
Thank you,
Request
ma'am.
all participants to enter your registered mail ID in the attendance sheet as well.
So एक
So
बात
that,
आप
yeah,
मंजुला
if
मैम
already entered, it is okay.
Can I?
Otherwise, yeah.
अच्छा, okay, thank you.